Good morning, and indeed it's my pleasure to be here within, I could see all professionals here, and I must appreciate Avneet his effort, and one of the very professional conferences which I was ever attended was in Ahmedabad when same topic was discussed, and the vibrant city in Ahmedabad and vibrant people there. I could see that there was a lot of professional outcome of that conference. Continuing with the same, when Avneet told me to be here and talking about the projects, my topic is little overlapping, and I am just trying to understand, between the sustainability and how the structure can be one of the components in terms of creating mega projects. So I would rather take you through the, my friend has given you the real insight of Chennai, in Calcutta airport. And, we were fortunate that that time about now, I think 8 years back in 2007, there was some global competitions, and we were fortunate that in India, we were thinking of such large span structures and such mega projects of such high magnitudes in financial, of 2,000 crore or 22,000 crores of project. And the type of, and then, working with the bureaucracy, with the government, with all those things together, and in the global contest, I am really fortunate that we were able to complete these two mega projects in a time-bound projects in a very professional manner. So I'll also take you into some of the nitty-gritties which we were also fortunate to get, won the global competition for Chennai airport. And my friend has shown you about Calcutta airport. We'll also discuss about how the engineering innovations can really make marvels, and how the last mile structures can create difference in creating new dimensions and new environment in new build forms. Beside that, my first topic to discuss is that how do you create some sort of a sustainability, and I as a mission take that, we should not take building as a mass of concrete and brick, but let us take this as a living organism which breathes, which has a component of, life, and it should be embedded with nature. And let's see that how we get to learn from nature. We have everything in nature, whatever structure we're talking about, it's nothing but inspiring from the nature. Maybe a banyan tree, you see this is about 250 years old tree, and you see all the branches, column, integration, we talk about main structure, then we talk about the purlins, we talk about the cross trusses, everything inbuilt, and this sustains for the last 250 years in a diameter of about 2.5 kilometers. We need to respect our resources. Why I am very conscious is that today everybody talking about green building, but we need to be very realistic when we talk about planning. We talk about how to design a building. As an architect, we have more burden than anybody else, that we need to see and conscious about how the city has to grow. We need to see how we preserve water, we need to see how we preserve our air and the mother earth, and of course the sun. We need to see how we go from linear to loop, we use everything, we recycle, and we do not make anything which is in a absolutely linear mode. Last is that we need to see how we use maximum solar energy, and what we are now also practicing. All this needs to be embedded into how we really socially interact, and in the society we penetrate this, and every one of us is conscious about how do you really conserve all that, and we make our cities green, we make our house green, we make our everything green. Now when you talk about mega projects, I'm just going through it because now we just talking about how the sustainability can work, and can we really think that our mega projects, which are energy guzzlers, can also be, in terms of, they are also, we can save energy and conserve our resources. And beside that, we need to see that our projects needs to be global. It has to be high-span, structures. I need a panoramic view in a mega project like an airport, all that, but within a financial constraint, and also within, needs to be interwoven as a sustainable project. Talk about Chennai. This was a 2015 crore project with an area of over 2 million square meters, and we were, this was a global competition, as I told you, and we won this. And I would just, इसको ऑन कर दो. But I just wanted to show that video to you, that how an architect gets inspirations from. When we were doing the Chennai airport, we said, let's see that, when you design, let's get a concept of inspiration from a bird and wings of the bird. That is what we tried to do, and I was just showing you that from the wings, the aircraft flying, And this is what from the bird's wing, we took out a shape. Okay, let's see that how the wings of the bird can give me an inspiration in forming a shape of the terminal building. Some of you must have visited Chennai airport, but some of you who have not visited Chennai airport, it has, it's a linear development. It's a very site-constrained place, because the city side is very, very constrained, and we have one as 4 million capacity of international terminal and another 6 million capacity of domestic terminal. We had a lot of pressure for the site, but we, in the initial stage, could only visualize to make a domestic terminal of about 10 million. Then we try to, see that how, because there was a requirement of international airport also, expansions, and we were able to put in another 4 million of international terminal. But on both the sides, and between the two terminals, the distance is about 1.2 kilometers. So there are many factors. One was the connectivity, how to connect the international to the domestic, because there's no place in the city side. We have to really take care of. Why I'm expressing all these things are that when you really go in hand in glove with engineering innovations, the engineering knowledge, along with the architectural vision, can create something which is beyond imagination. That is what, when we were trying to make our Chennai airport, and we were making an elevated road, the concept of making the elevated road and the type of structure which was there, we really mingled with the engineering and saw that how the basic requirement, the architectural functional requirement, can be infitted within the engineering capabilities. Beside this, we were very keen that the airport, the terminal building needs to have the basic passive strategies of architecture, the green elements. Let's see how do you respect the orientation. Let's see how do you envelop the building. Let's see how do you really place your building and minimizing the heat gain in the building and maximizing the light. So these were the factors. We came into the functionality of the building, how really the airport works. You need larger areas when you check in, then you squeeze in, then you come into the security, then you come into the larger area which is called the hold area. So all these things were contemplated, and then from there we could see that it's something which is like an edge. We get a sort of a vacant space between this, and which we created as a green spine and created an edge-shaped building which has more of an exposure on the areas on the north and south to give me light within the building, and also I get the plate which has light from both the sides as well as create the inner spine as a green area. So this is how we shape out the building, and in terms of orientation we place the building in a north-south fashion, and my air side which is north and my city side which is south. On the air side I have a cantilever of about 12 meters, and on the city side I have a cantilever of about 25 meters. So on the south I do not get the southwest sun which penetrates into it, I get shade. So similarly other elements were also put in, like insulating the complete envelope in terms of using double glass, in terms of making ACC blocks, in terms of making my double calzip roofing, and the complete envelope is insulated and the heat load in the building is minimized. These are the finished building, actual photographs of the building. Now I talk about the various innovative features which are there in this Chennai airport. We have the largest span, which is 24 meters, and in a simple truss form, one of the largest, I would say, in any of the airports, cantilever structure. Now I was talking about the engineering innovations, and this is what a conventional flyover would have been. But here, when we're talking about, I have my international airport on one side and the domestic terminal on the other side, and then an elevated road, the engineering innovation created me a V column. A V column so that I have an insert within the V column which can give me a space where I can have a sort of a connecting tube with some sort of I have about 28 vocolators in the tube, so connect domestic to the international. Otherwise, I was not able to get that sort of a space, and this is only because of these V columns. So one was the V column, other was how to reduce the thickness of the flyover. There also, the engineering skill made me confident that, okay, I can reduce the box section girders to only 400 mm, which are hollow box section steam cured girders. Probably first time in India we've done this in steam curing and box girders, which are only 85 mm thick, I would say, rather beyond the IS code itself. But this we got it executed and minimize the thickness of the flyover so that I gain the height below my flyover to insert my tube wherein I can have the connectivity. These were the V columns, very difficult to construct, but nevertheless this was done. These are practically 4-legged V columns. You can see this, you can see this is I am talking about to reduce, we have the more height here. This is just 400 mm hollow box section girders. V columns. We maintain the same vocabulary of the V columns structurally in the building as well as in the flyover, so that there is a homogeneity and there is some sort of a concept in designing. Then within the V columns, we have this as the glass connecting tube. You see this? And this is how the mock-up at site is, that after finishing, this will be the connection from the this international terminal to this side as the domestic terminal, which are far away as 1.2 kilometers. This is the now arrival tube. When you arrive, there is a glass tube, which is also a very architecturally a very novel feature. You see this, which has a large span, and we have the green spine in here. So when you come in, when you arrive from the aircraft, you are passing through the arrival tube where you see the green and you feel very comfortable and soothing. This is another feature. We have a small canopy below the large canopy, which gives me shelter from rain and sun for the human, which are the passengers, but also it is giving me a functionality of putting my lights, the uplighters and the downlighters, so that I can lit up the structure above. So this is the finished view. These are some of the photographs when the construction was done. And here, we actually were the first one who could really bend in hot bend pipe of 508 diameter here in India. Previously it was not done here, it was done from outside, and here we practiced it here, and we were able to bend this pipe here, 508 mm diameter pipe. This is how erection was done with the crane on top. This was this truss knot that we didn't put it in one piece and then, as in Calcutta, then it was erected above, but this was in segments, and the segments were put on top. And there was a lot of care to be taken in terms of the lateral movement, the wind pressure, the other things during the process, so that there is the possibility of deflection is minimized. This is how the erection was done. Just giving you a feeling of the V columns. V columns are a part of 28 meters, and they practically, and it has a span of 30, the structure is about 35 meters high and a span of 35 meters on this side. And then there is a saddle which is here in between from one truss to another truss. Then there is a dip and a saddle which gives me a panoramic view. Otherwise, I can see my air side, I can see my city side, and I can see my security area, and all in one. And mind it, in this structure, there is no false ceiling. Everything acoustically has been treated in a manner that the whole structure is apparently and visibly, visible, and you can really have the feel and taste of the real exposure of the structure. When we're doing this, I'm just trying that how the steel can help us out in various other elements. And here, when in the process of designing, when we're creating our infrastructure, when we're doing this, the metro came in between, and there were a lot of, discussions that whether the metro has to be underground, our ground, or what, and ultimately we were forced to give a space to the metro in the constrained city side. And that, we try to put in that metro station in the city side, which is hardly, because if you have been there, the flyover is just abutting on the terminal building. But we tried that how to put in the metro so that the terminal buildings are also not practically, architecturally and visually diffused. So, we could make that, in terms of that this is one of the airports or one of the facilities where 4 modes of transports are interconnected. This is the first place which is in India, I would say, the 4 modes Intermodal Hub. We created an Intermodal Hub here where the surface, the railways, the air and the metro is fully connected. You come from railway, you can come to the airport. From airport, you can go to the railways. From the metro, you can come to the airport directly without coming outside. So it is all connected with about 35 walkolators and the glass tube around. This is the metro station, all done in steel. These are, this is all steel portal again, and this is the under construction photograph. This is the glass tube again connecting. It has commercial and retail area within. You can see this. This building has the retail and other commercial areas. Just briefly about how the structure in terms of pipe we used in Chennai airport. Now I'll take you to Raipur airport, where again it is steel and a structure which has double curve, which is very difficult to make, but it has been done. So I'll also share you with what were the difficulties, what were the various things which happened, and how we really resolved them. So this is Raipur airport, which has also won the best airport award by Government of India. And this is the roof profile of the complexity of the roof profile of the avion roofing, which we tried to give, and also the skylight within the terminal building. It has 3 columns. On the RCC column, the 3 columns comes, then you have the trusses on top, then you have the cross purlin, and then you have the wings, which has double curve. This is how, you know, broadly it. Temperature is 22 degrees, then the condensation takes place, and from the gutter sheet, the water starts dripping out, so dripping down. So it, you know, after doing all that, if the water drops, then again, you know, it doesn't look good. So what we did here is, even the GI sheet in the gutter is in double layered, and we have insulated that so that in terms of condensation also, there should not be any tendency of any drop coming down. You see the gutter detail. This is the photograph when the work was being executed. This is a 3 column. Now I'll just share you my experience that how, you know, what happens is in these type of projects, when you talk about the interface between the RCC, the steel column, the roofing, and the facade. This is very, very important. And you know what happens that when you get your shop drawings, the civil drawings, and then the shop drawing is steel, there's a mismatch, you know. The foundation column is at one place, but at the time of execution, maybe there is a variation in the center line of the column, and when it comes to top, and you're trying to put your the 3 column on top, if there is a variation, then you try to fiddle around with the structure. And that is what happened exactly here. You know, this is how the erection was done for my 3 column. And this is I wanted to share with you that we are still to be experienced. We need to learn many things, you know. And as my friend told you that, you know, in today's contest, we are contesting with global world, but we are not that. I would rather say that our professional methodology, system of working needs to be improved, and where we say that yes, we are no less than global. We need to address these issues in terms of in terms of quality. And how do you ensure that? That has to be seen. We learned many things from during the process of this, that yes, it's not difficult, but definitely there needs to be an attitude towards learning and experiencing and doing something better. This is what happened. The column cracked, the concrete gave way, because the contractor started to fiddle around with the tree column and wanted to put it in the foundation bolt below. You know, if the alignment is not proper, you will find these issues and problems. So one has to see that in these type of structures, this is very, very delicate, and you see that all this is cracked. And this is all, you know, the reinforcement is coming out, and he is trying to put in the upper steel, my tree column on top. This is what you see, the misalignments. But ultimately, after doing all this, we were able to achieve this, and we were able to finish this. Similarly, this was very peculiar, making an eye here, which is again double curve. I mean, there's a deflection on both the sides. And then resting this here. I'll show you another slide where this is not coming here. It is coming somewhere here. So these are finished. You see the various moods of the airport in the daytime, in the night time. You know, we tried to play with the light. We played with the yellow light. Let's see the, you know, inner visual impact. You know, give a sort of a feeling in the yellow light, and in daytime you have the white light feeling. And this is what you see, that when you construct and you behave like this. So these are some of the, I do not know what is the factor of safety which my friend will take into these type of structures, you know. When the quality works like this and you have these issues, then you put this piece here. You know, these were some of the challenges which you face. And ultimately you can't demolish the whole building which is being erected. So how do you make the modifications? How do you see that the imperfection can be corrected to a perfect level, to a level where we can really digest it? See this. Now, once you're doing it, you leave these gaps. So, I mean, these are certain things where the engineering, supervision, understanding, methodologies, welding lengths, type of welding which you are doing, the various other professional characters needs to be addressed. See this. Now what happens here, there is a difference of 900 mm.
You can go back.
Yes, sir.
Previous slide.
Yes.
Just for the, you have this pipe is wrongly cut. This should be cut in such a way that it fits.
Yes, that is what I'm trying to say. It has to fit in, but you know, it is not fitting. So now these are neglected. So I mean, even the site engineer is sitting on the ground, he is not aware of, till the contracting agency is professionally, you know, committed to do something. So you can't work like a policeman, you know, and see all these details, and you are on to a person, you know, and just educating him in all these issues. So that is what is required. The contracting agencies needs to address these things. They must have a complete team where everything is being monitored properly and then delivered. So, I mean, as he has rightly said, I mean, he is some, I mean, a person who can really, you know, I mean, we need to learn from in the engineering. But, you know, as an architect, I see visually, these are some of the remarks which has not been given by some engineer, but by us, by a common man, by an architect, you know. And if suppose we go to the site and see this mismatch, how will he do it? Either he will, you know, make my tree in some other odd shape, or he'll do some other way. He tried both the ways, muscular way to fiddle around and put it like that and put it here, jagging, that will create some sort of a demolition and some sort of a crack somewhere else. So these factors, now you see here, again the misalignment is about 200 mm.
But before you accept
Beg your pardon?
A good analysis must be done before you accept it. The safety has been
No,
guaranteed.
no, acceptability is something different.
Not acceptability.
Maybe that even in today we are not accepting it, you know. But what I am not debating upon the issue in terms of who's doing what, but I am just highlighting that these are the things which are being experienced.
No, agreed. My question here simple is that before all these things are deviations, and before you accept it, even you or anybody concerned, it should have been made safe from sexual consideration.
सर उस समय आंखें बंद कर लेता बंदा.
नहीं वो
सर मैं बताऊं सर, वो सरकार है. सरकार के काम में सर ऑल ऑफ अस नो हाउ द थिंग्स आर डन. ये कॉमनवेल्थ गेम हुई, दूसरा हुआ, उसके बाद आंखें बंद हो जाती हैं. कोई एक्सेप्टेबिलिटी, एवरीबॉडी सेज आई हैव नॉट एक्सेप्टेड बट पेमेंट इज डन. You know, that is something different. I am not advocating that. My concern is that as a professional, we must sincerely see that we deliver. We must understand. Yes.
So these things need to be done.
Yes.
In today's stage, need to be done.
Done.
Issue of safety.
Yes. So now I have explained you about this. I'll explain you about again this. I just wanted to show you these, that because these are not talked about. These things we do not talk about, that what are the deficiencies. We always, I can show you very good videos of, you know, that what we feel like doing, what we do that. But this I show you, this is what our inner cancer is. You know, this is how we work, how we perform. You know, ultimately, we got the best airport award for this. You know, that visually it is very good. But these are some of the things which, you know, needs to be seen. Hey? Okay. I'll just finish 10 minutes. So this is how steel can be in bow trusses. We use this either in tubular or in eye girder. This is how we did the ticket counter, and finishing like this, airside corridor, finishing, then the various other elements, and this is what is our landscape area within the Raipur airport. I'll skip over these some of the photographs, and this is how the landscape. If you see, my car park is all green. You know, even where car is there, I have put polypropylene paver blocks, and it is all green. You see this, the car is parked in the green lawn area. We have solar, we have lake, we have storage, we have all. This is a green airport. These are some of the other visuals. This is how it looks at the night shot from outside. This is Goa airport, again steel, all steel plate portal. There we were talking about tubular, here it is all plate portal. Again about a lakh square meter of area with about 400 crore project. Finish photograph. This is, we're doing the connectivity between Raipur and Naya Raipur. We have 4 stations here, and we have the railway track, we have intermodal hubs. These are the stations which we are doing, and this is the drawings for the station, the intermodality, and we're using the steel portal. These are some of the stations in Bombay, Washi, which we're doing. Here, I'm just trying to express upon high-end architect things and how the engineering can work. See, there are various types of structures. One is, I say, like, we put it like, you know, this thing, folded plate structure. So one we say that it is a tubular structure. One we say that it is space frame structure. You know, all that. And when talk about, we had an opportunity of making 3 designs for 3 terminal buildings. In one we said, okay, we say that we make a design in terms of, you know, space frame structure. So here we tried that how the space frame structure can give me, the engineering can give me an architecture. So this is how we try to create a railway station with a space frame concept, the canopies, the entrance, the everything we tried with the space frame nodes. Then we said steel structure, only steel truss structure, how it can work. So with this steel structure, we tried to play and we made this structure. And this is in steel plate, portal. So we tried to put the portal here, and you say this is a form of the portal here, and this is in plate. This is another large conventional facility where also steel in a large span structure. This is a sort of a convention facility with 5,000 people capacity, and it has 1 basketball court with 4 badminton courts, and this is box section. Now you see this, you see this, you see this, the whole roofing has been done in box section, and it has, even the balcony a girder is in box section, which has a, all this, which has a span of 30 meters balcony. This is the inner view of the convention facility, 30 meter span of the balcony. Another project which we're doing in Nya Raipur is Times Square Mall. Here I'm just saying that how we can really think of using steel. We are using a second layer in the structure as steel. From the mutual shading, we tried this. This is a non-air conditioned mall. We used all the simulation how to see that we maximize the light and minimize heat gain in this non-air conditioned mall. We have step terracing, we have complete, we analyze this in terms of how the lower system can work. And this is the top lower system, and inner space, and then the outer skin. Outer skin is again steel framework with a double skin, and on the outer skin you again put posters, you put your advertisement so that it gives shade to my inner building, and also it has a variable visual appearance all the times. So this is how we can emphasize upon use the steel in these projects as well. And this is, we're doing the, 5 of the stations in, as intermodal hubs in Ahmedabad Gandhinagar Metro Link. These are the 5 Akshardham, Wadaj, Paldi, AEC and Koba station. This is Koba. And these are the other 5 stations where also steel is being used for all the structures with large span. We are into various sectors of working. This is what we do. We are also into the city planning. We're doing Jamshedpur city, their vision 2057, and trying to create something in terms of real, sustainable, green cities. That is what we ambitiously do for. And Jamshedpur will convert into a park within city, city within a park. That is what we're trying to do that. And our mission is that let's see that we go beyond net zero. We make every building as net zero energy, net zero in water, and net zero in solid waste. Thank you very much.